So hello everyone, welcome back to my YouTube channel. And today we're discussing about statement testing and the overview of software testing and all that. So firstly, we'll start with the introduction of software testing. Software testing, like generally, what do we think about software testing? Like whenever a software is about to get deployed into the market, or when it is about to get released into the market for people to normally use it, it goes through many stages where people from a certain organization that are deploying it actually test it if it's proper in all the conditions, if it's working well in all the test cases, if there are any errors, just because the users shouldn't feel any kind of discomfort while using their application. So for that, they actually undergo many stages of testing, and all these stages come under software testing, where we test the software under multiple conditions and under multiple cases, so we can give the users a perfect software to use. So technically, we'll look at the definition now. Software testing is a crucial part of the software development process, ensuring the quality and reliability of applications. It involves systematically evaluating and verifying the software meets and its requirements and functions as expected. So nextly, we'll look at the overview of structural testing. So firstly, the code analysis. Structural testing examines the internal structure and logic of the software code to ensure it meets requirements and functions as expected. White box approach. This testing methodology focuses on the internal working of the software, requiring detailed knowledge of the code and implementation. Here we actually know the whole detail of the code that we're working on. Test coverage. Structural testing aims to achieve high levels of uh, test coverage by exercising different paths, branches, and conditions within the code. So yeah, as I told earlier, like under different circumstances and like different conditions, we actually test the code whatever we are about to run to deploy the certain software. So test design. Test cases are designed based on the internal structure of the software, such as control flow, data flow, and decision points. Principles of structural testing. So firstly, it's coverage driven approach. Structural testing focuses on ensuring the coverage of the application's internal structure, such as lines of code, branches, and conditions, to identify and address potential defects. So it takes care of everything, like every step that I told you, so as to, like, there should be no errors, the app should be working perfectly. They take care of everything, like they go through the whole thing again, they test it perfectly under all the conditions. Yeah, next is the white box perspective. This type of testing takes a white box approach, where the internal workings of the software are known and can be used to design effective test cases. So designing test cases is actually a very important thing to do while testing, because we can't just be giving random test cases and expect the software to run properly under those test cases. We have to take care of all the possible test cases, like right from the boundary value approach, like whatever we use, we check for the boundaries first. If it's working fine for the boundaries, then it obviously will work fine inside the boundary too. Yeah, that's what it is. So firstly, we'll check for the boundaries, then we'll go for the nominal values. Nominal values means the central values. Example, if we're testing for numbers from 1 to 10, then 1 and 10 are its boundary values. We check for 1 first, then we test for 1. I mean, for 10, secondly, after 1, we test for 10. And the nominal value, the one between 1 and 10 will be 5, obviously. So that will be our nominal value. So we'll be testing even for the nominal values. Then we'll make different relations of numbers, and we'll even at times we'll even test for values which are outside the boundary. If the outside the boundary values, like the values outside the boundary are giving us proper results, and it should basically give us whatever we're expecting it to give. It's a systematic approach. Structural testing follows a systematic approach where test cases are designed to exercise specific elements of the application's structure, ensuring comprehensive coverage and identifying potential vulnerabilities. So, vulnerability, nothing here is, vulnerability here is the errors that we'll be facing. So yeah, we'll check out for all the errors that I told you earlier, and if there are any errors, we'll just backtrack it. We'll go to the stage where the code was actually written, and then we'll ask a certain person to write the code again, so to avoid the error completely. So statement coverage. Statement coverage is a structural testing technique that ensures every executable statement in the code is covered by at least one test case. Every statement should actually be given a single test case. If it's working fine under that, then Yeah, obviously we can go further. So yeah, every statement should be checked. It shouldn't be like, oh my, this statement probably doesn't have any errors. Let me not give it any test case. So that can't actually happen. It might give you errors if you actually go further without reviewing the certain statement. So it measures the percentage of statements executed during testing program being compared to the total number of statements in the program. Yeah, the same thing. The total number of statements covered divided by the total number of statements in the program. So that's how the average works there. So by achieving 100% statement coverage, you can be confident that all lines of the code have been exercised, helping to identify and fix bugs early in the software development lifecycle. So yeah, 100% statement coverage means all the statements have been covered. Every statement has been given a minimum of one test case, and the test case has been run successfully. And only then we can say that the statement has 100% coverage. So after a certain statement gets 100% coverage, or the set of code gets 100% statement coverage, we can move to the next stages. Decision coverage. Decision coverage is a testing technique that ensures all decision making logic in the software is exercised. It requires executing code paths where decision results in both true and false outcomes, validating that the software behaves correctly in either cases. So, example, if the value of A is 5, then how to check if the value, consider we have given the value of A to be 5, and if the value of A is 5, then we should give the condition as yeah, the value of A is 5. We'll print that statement. If it's not 5, then we should also print a statement that the value is not 5, it is something else. So we are checking for both the statements here. If it's true or if it's false, we should take care of both the statements, not just concentrate on the positive statement. In that case, um, we can't actually be very efficient with the ones with the values that we are not actually getting there. So we should cover all the stages basically. This coverage metric helps identify logical errors such as missing decision conditions or incorrect branching logic that could lead to software failures. So everything must be taken into considerations that I've told you. So condition coverage, evaluating Boolean expressions. Condition coverage ensures that each Boolean condition within a decision statement is evaluated both true and false during testing, verifying the logic, and etc. Comprehensive verification. By testing all possible combinations of conditions, condition coverage provides through validation of the program's decision-making capabilities. So, measuring test effectiveness. Tracking condition coverage metrics helps access the completeness of the test suite and identify areas that require additional testing. So, a few areas in the code actually require additional testing, right? So, these are the areas that are actually prone to errors more than any other areas in the program. So we actually have to like test that certain code multiple times with many test cases, so it'll perform well under all the circumstances and not just one or two and then give error in the third test case. I mean, that's not an efficient program then, right? We have to give in multiple statements, and it should actually give us proper outputs in all the test cases that we give. So modified condition or decision coverage. So we actually modify it a bit and we'll see what the modification is all about. Comprehensive testing. Modified condition or decision coverage aims to provide more thorough testing by examining each condition in a decision statement independently. So it checks for it independently. Logical combinations. MC or DC, which actually means modified condition or decision coverage, ensures that all possible logical combinations of conditions are tested, going beyond basic decision coverage. Yeah, the same thing. Complex conditions. This technique is particularly used for testing complex conditional logic, helping to identify edge cases and potential bugs. Overview of statement testing. What is statement testing? Statement testing is a fundamental technique in software testing that focuses on ensuring each executable statement in the code is tested at least once. This approach helps uncover errors and validate the correct implementation of individual program statements. So, next we'll see the importance of statement testing. Statement testing is crucial because it provides a comprehensive check of the code's logic and functionality. By verifying each statement, testers can catch issues like syntax errors, missing logic, and incorrect variable assignments. Measuring statement coverage. Statement coverage is is a percentage of executable statements in the code that have been exercised during testing. Achieving high statement coverage is a key goal, as it indicates a thorough testing process and increases confidence in the software's reliability. Techniques for statement testing. Some common techniques for statement testing include white box testing, path testing, and code walkthroughs. So white box testing is something that we've already studied, and also path testing, like the path that we're actually taking. If it's actually correct, we'll be testing that. And code walkthroughs. Code walkthrough is nothing but we'll go through the code again to check if there are any errors, if we have missed any area of the code that we should be reviewing and all that. So these approaches help testers systematically exercise each statement and identify any gaps or defects. So yeah, basically the final goal is to make a software which is completely bug free. I mean, it's hard, but I mean, this is what developers or creators actually want to do. I mean, this is what they want to do actually, but under like unlucky circumstances, they actually get a lot of errors and bugs. And yeah, if they fix that, then they can actually make a complete product. So yeah, this is what everyone hopes for, that their product shouldn't have any errors. It should run properly under all the circumstances and all the conditions and all the test cases. So the users, I mean, which is us, actually get to use the product in a very efficient way without any errors, and we shouldn't be complaining, and which in turn will actually help them get profit for their own business or their own product. So this is all about the software testing, the statement testing, and the structural testing. So I'll be back with more videos. So stay tuned for that. Thank you.